Hi, my name is Ali Spiegel, and I'm going to be going over the 2019 AP FRQ question number 5. So here's the problem, and as you can see, we're given a shaded region on a graph, so we can infer that out of the types of FRQ questions, it's the area between curves and volumes, and a tip is that we'll be using cross-sectional volume or rotational, and we have to know the disk, washer, or shell method. And then I just used integrals and learned methods from class to solve these problems. And so what I first did for problem A is I just graphed my slice on the graph that was given in the problem and labeled them. So finding the area of R, so what you have to do is you're going to be finding the integral of the upper region minus the lower region. So I knew that h of x was the upper graph because if you go back to the problem, what I did was I substituted in 0 to find the y-intercepts of both graphs, and then when I substituted in 0 for h of x, I found that the y-intercept was 4, and then when I did the same thing for g of x, it was 1, so then I could tell that h of x was the upper region, and then I took the integral of each side, and I substituted in each equation, and then I simplified, and then I'm using fundamental theorem part 2, and then I subtract, and then simplified, and I eventually got 44 over 3 units squared. And then for part B, we're finding the volume of the solid given the area of the cross-section. So since they give you the area of the cross-section, we're just finding the antiderivative of it. So here I just plugged in the limits of integration and the area that they gave us, and then I just found the antiderivative, and now I'm using fundamental theorem part 2, and then I'm simplifying, and then I got ln 5 over 3 units cubed because we're finding the volume. And then for part C, we're finding an integral expression for the solid generated when r is rotated about y equals 6. So here's the graph, and I just put the slice on it. I just drew the slice and labeled the coordinates. And then here's the axis of rotation, which is y equals 6. And we know it's the washer method because there's a gap in between the equation and the axis of rotation. So we're doing big disk minus small disk, and since g of x is furthest away from the axis of rotation, it's the bigger disk, because it creates when it's rotated around y equals 6, it creates the bigger disk, and then the smaller disk is h of x because it's the closest to the axis of rotation, so when it's rotated around, it creates a smaller disk. And then I just wrote down the equation, which is pi equation squared times change of x. And then we're taking the integral of it, and then I just combined the equations. And I had to do 6 minus the equation because the axis of rotation is 6, so we need to find the difference from the axis of rotation and the equation. And yeah, that's it. Thank you.